Hi everyone, welcome to today's video. So today we'll be talking about 3 design principles that have helped me write cleaner and more testable code over time. So let's get started. So let's talk about the first one. It's about identifying aspects of your application or code that keeps changing over time and then separate them from what stays the same. Now, this is a lot in line with the open-closed principle as well. If you just think about separating parts of code that keeps changing, you're isolating those changes. Now, what happens over time is that all of the other classes that were currently having this code that keeps changing over time, now they don't have to be opened every time, made changes to the code, and then tested all over again. So it makes your code cleaner because you have isolated these changes in one place. That's the only part of your application that keeps changing over time. So it doesn't break any other classes that it actually is being used in. The second one, as I like to call it, is abs. So basically depending on abstractions and not implementation. Easier understood as programming to interfaces and not implementation. This principle now, in opinion, makes your code much more flexible and more testable. Your classes now depend on interfaces, and so you can have one implementation today and just use a different implementation tomorrow when required. You don't have to go around making a lot of changes to your existing classes. The second aspect of this principle is testing, which I think is very powerful. It becomes much easier to test code that depends on abstractions over concrete implementations. So today, if you have a class A that depends on another interface B or just has another interface B, what you would do in code is that have a concrete implementation being passed at runtime in your code implementation, and you can easily have just a fake implementation for that interface which is being used in your test classes. Now you don't have to go around creating mocks for your concrete implementations and writing all of that when then logic. You can just use your fake implementations and write much cleaner tests. The third one is composition over inheritance. Now we talked a lot about interfaces earlier. Now someone has to go implement those interfaces, right? So let's first understand what has a relationship versus is a relationship is. So for example, we have an interface engine which has some methods x, y, z. Now there is a class car which can either implement this engine. That means car implements engine, so car is an engine. And the second option is that car has an engine. So car's constructor basically just takes engine as a parameter. And then when you're instantiating the car class, you pass in a concrete implementation there. So you now see the difference between has a and is a. Is a is when car directly implements the interface engine. And has a is where car is basically having a type of engine interface or engine class in its constructor itself. So has a refers to composition and is a is basically inheritance. And let's understand why has a is so much more powerful than is a. When you have has a relationship, your car has an engine, which is an interface today. So right now I can have one implementation for the engine interface, which can have certain logic. And tomorrow, if the logic changes, I can easily pass on another implementation there. Or if I have to run some experiments with two different logics or two different UI, for example, or things like that, I can easily write code that has two different implementations, which is being passed on at runtime. And you can have one implementation based on the XP check. If you are having a is a relationship, the car directly implements the engine interface. How would you then change it, or how would you then easily extend it if required in the future? You would have to go open the car class and change the implementation that it has for the engine interface, and that doesn't scale well. That's why having a composition logic over inheritance directly makes so much more sense. Makes your code easily extensible in the future if the logic changes or designs change, and it also makes your code easily testable. So hope these design principles would help you write cleaner code. If you want to know more details about any of the design principles that I talked about, please let me know in comments. Thank you.